Hello, good morning, student. How are you? I hope you all are fine and happy at home. What did we discuss yesterday? Let us recall it or let us revise it. Yesterday, we learned or we discussed about the hybridization. We have discussed by using as a various atomic orbital how the hybridizations are takes place, as well as we have seen the cleavage of bond, homolytic fission as well as heterolytic fission, how they occur during the course of reaction. That type of the thing we have seen. So yesterday, by using S and p orbital only, there are so many atomic orbital like s orbital, p orbital, d orbital and f orbital. Out of that, at a F.Y.B.Sc level, we are going to learn only the two orbital which is useful as far as organic compound is concerned. So by using as a s and p orbital, we can have three types of the hybridization. Yesterday we have seen how to identify what type of the hybridization present in the given organic compound. There are three type of the hybridizations are present. One is called as a sp3 hybridization, second one is a sp2 hybridization, and third one is a sp hybridization. And as we know that hybridization means what? The process of mixing and recasting or redistribution of atomic orbital of different energy in an isolated atom when they overlap to form a new set of orbital which is equal in energy is known as a hybridization, and the new orbitals are called hybrid orbitals. And yesterday we already learned formation of the methane molecule by using the same principle. Today we are going to learn formation of ethane molecule. And as we know that ethane, first family of alkane is a methane, ethane, propane, butane. Everywhere the hybridization found to be sp3 hybridization in a saturated organic compound, means organic compound containing carbon-carbon single bond. They shows or they indicate sp3 hybridization, and they are known as saturated. Means theoretically you should remember the saturated means what? The organic compound containing carbon-carbon single bond. That type of the organic compound are called saturated compound. Now let us look at here carbon-carbon. Here CH3, CH2. Here also as a carbon atom is a central metal atom. So what we have to yesterday we have seen central atom in methane molecule also as a carbon atom, and as we know that carbon atom has a atomic number is a 6. So write down the electronic configuration on the basis of by following as a above principle: 1s2, 2s2 and 2p2. And as we know that 1s orbital is a inner shell orbital. It does not take part in the formation of the bonding. Only valence electron, there are the 4 valence electron present. And as we know that valency means what? Valency means capacity to form the bond with the other element is known as a valency. And therefore carbon atom is a tetravalent, means it has a 4 valency. And now here 2s orbital, and as we know that p orbital has a 3 subshell. Now this is a 2s orbital. These are 3 subshell orbitals of p: 2px, 2py and 2pz orbital, right? Now as we know that while filling the electron in the subshell, 2s orbital, it containing 2 electrons, and that 2 electrons are opposite in spin, and now p orbital has only 2 electrons. One is entered in px, second one entered into as a p1. So that is a ground state electronic state. And when the molecule is formed like as a methane or ethane, what is happening? If you look at here, there are the 2 unpaired electrons in the ground state, but in an actual sense the carbon has a 4 valency, because there must be 4 unpaired electrons, otherwise there will be no formation of the molecules are there. And therefore what is happening there, when the molecule is formed, that carbon atom goes in the excited state, and from here the energy come for the excitation, the energy which is coming from the sunlight, and that's why 1 electron promoted from 2s orbital to the 2p orbital, and therefore we are going to get here, look at here, there are the 4 unpaired electrons. And then when according to our definition, the mixing and redistribution of atomic orbital, these are the different atomic orbital, yes, and px, py and pz, these are the different atomic orbital, and when they mixing together, overlap together or hybridize, we are going to get the new orbital which is known as a hybrid orbital. And here in this case sp3 hybridization, this is a sp3 hybridization. Hybridization, right? Hybridization, when hybridization, sp3 hybridization, it has a definite geometry. What kind of the geometry it acquires? It acquires the tetrahedral geometry. There is a tetrahedral geometry is found, and as we know that what is the bond angle of tetrahedral is always 109.5 degree. Remember, tetravalent, regular tetravalent has a bond angle is a 109.5. Now yesterday we have seen in case of the methane molecule, here and then s orbital are spherical in shape, p orbital are what we can call it as it is a dumbbell in shape. You might remember in your previous day, not now, but when I was in a school, there is a PT lectures, and during that there is a dumbbell. So in that the dumbbell has a 2 lobes are there, therefore that is the shape of that p orbit. Now yesterday we already learned that how that hybridization takes place. Look at here again. Listen the carefully. If you pay the attention from the beginning, you will be well on the track to understand the organic chemistry. And therefore look at here, this is a spherical shape, and as we know that there are the 3 axes, x, y and the z axis. All the electron density spread or distributed along all the axes is the same, because it has a spherical in shape, and therefore this is a 2s orbital, second one is a 2px orbital, and 2px orbitals lobes are like this, dumbbell shape, right? It's very easy. And then px orbital means what? Slightly in this manner, and then it is a 2py orbital here y orbital, this will be the x, and next one is a 2pz orbital. 2pz orbital, the axis is like this. So z orbital, 2pz orbital, when they hybridize or overlap or hybridize, what do you get? We are going to get, and when the hybridization takes place, if you look at only as a one sp3 orbital, one lobe is a larger and one lobes become as a smaller. So this we can call it as a sp3 hybridization. Only one sp3 hybridization, but there are the 4 atomic orbital, and always remember number of atomic orbital involved in the hybridization, number of hybrid orbital are obtained, means number of atomic orbital is equal to number of hybrid orbital, and therefore number of atomic orbital, if you count here 1, 2, 3 and 4, how many hybrid orbital you are going to get here? You are going to get 4 hybrid orbital. And how they looks? They are looks like this. Look at here, that is a 4, this is a 4sp3 hybridization, right? 4 this sp3 hybrid orbitals that is found here. Now what is happening there? Now when the ethane molecule is formed, one of the sp3 hybrid orbital, and now remember, yes, when that sp3 hybrid orbital is formed, it has a maximum symmetry, and second thing, remember, it has a definite direction, means orientation in the space, and therefore while overlapping, that hybrid orbital can overlap with hybrid orbital as well as it can be hybridized with atomic orbital, and therefore while formation of the what we can call it as a ethane molecule, now the one sp3 orbital of one carbon atom overlap coaxially with another carbon atom of the same ethane molecule, and the bond is formed, that is a sigma bond. Now let us look at here how they forms here. Now this is a sigma bond here. Let me draw this diagram here. The one sp, here is a sigma bond, and this is a sp3 carbon atom of sp3 hybrid orbital of one carbon atom. Remember, imagine here, this is one of the carbon atom, this is another carbon atom, and sp3 hybridization overlapping to form a strong sigma bond. We know that it is known as a sigma bond, and it is denoted by like this. This is a symbol of sigma bond, and it is coaxially formed, means maximum electron density concentrate between the two nuclei, and therefore sigma bond is a stronger. And now what is happening in the next case, another one here, one sp3 hybrid orbitals. Now the ethane molecule form sigma bond, another 3 lobes remain there like this, and here also, and the 4 orbital of what we can call it as s orbital, as we know that hydrogen atom having atomic number 1, so electronic configuration here hydrogen atom having as atomic number 1, so electronic configuration is equal to 1 s1, and therefore only one unpaired electron, and that 4 orbital they can form as a sigma bond. This is a sigma bond formation, right? And 3 hydrogen atom, and now one hydrogen atom here, another hydrogen atom here, and another hydrogen atom, they are forming as a sigma bond, H and H. As we know that there are the 3 hydrogen atom. This is a formation of sigma bond. These all are showing as a formation of the sigma bond. Now what is the overlap here? One s orbital, sp3 orbital of carbon atom, and s orbital of the hydrogen atom, they overlap to form as a sigma bonds are there. Means everywhere there are the 6 sigma bonds are there, they are the stronger one. Now let us look at how the carbon this ethane molecule is representing here. There is a carbon atom, and this carbon atom So we can show one of the hydrogen atom here, another hydrogen atom. Look at here, this carbon atom, hydrogen atom, carbon atom, carbon atom and hydrogen atom, they are lying in the same plane. And now we can show, this is the bond shown here, thick bond. Here also we can show as a thick bond that clearly indicate that the hydrogen atom are above the plane. And now we can show another bond here like this. This hydrogen atom, they are goes away from us or from below the plane. So this is a clear representation of the ethane molecule. This is the formation of the ethane molecule. I think this one we already so far we have learned as a two example, which is clearly shown by the sp3 hybridization. Now one more thing, remember here, when sp3 hybridization takes place, the bond angle, in any bond angle means what? The angle between a two adjacent bond is called as a bond angle. Now the bond angle is found to be, in this case, is 109.5. that is a identity of this tetrahedral. It always shows 109.5 degree. And now when the carbon-carbon single bond length is found here, let us see here, suppose is a bond length is a 109.5 degree, whereas the bond length in the carbon-carbon single bond, the bond length is found to be, I think, 1.54 angstrom. Always remember, this is a angstrom, it is a unit of the bond length. Means whenever there is a carbon-carbon single bonds are there, that X-ray crystallographic diffraction experiment indicate that there is a bond length. Bond length means what? The distance between the two bonded atom is known as a bond length. These are the two bonded atom, and the bond length is found to be 1.54 angstrom. These are the sum of the what we can call it as a point to remember while discussing the sp3 hybridization. What is your first job to do or first things to do? You know that you have to find out which is the central atom present in the molecule. First central metal atom, and then as we know that we are studying as a organic chemistry, and as we know that at the beginning I already told you that organic chemistry means study of carbon atom, that the study of compound that contain carbon atom is known as organic chemistry. And therefore you always remember the atomic number of carbon is a 6. Try to write down the electronic configuration is a very easy, 1s2, 2s2 and 2p2 in the ground state as well as in the excited state, because this is a hypothetical process, and therefore but it is a very useful as far as a organic chemist point of view is concerned. I think second one, let us stop today here. Remaining sp2 hybridization and sp hybridization we will see in the next lecture. So have a let us stop today here. Have a nice day. Thank you.